Welcome to Not Milk Never Milk. Subscribe if you're lactose intolerant.
You begin by opening Onshape and creating a document dedicated to this VEX assembly. Set units to millimeters or inches now, because consistent units prevent scaling errors later. Create a parameter table for motor, shaft, and hole sizes. That saves you time when you model repeated parts. Next, sketch primary dimensions from the VEX CAD spec, constrain them fully, and extrude the base features so you have a parametric foundation to build on. Once you have base parts, model each VEX component in its own part studio for clarity. Dimension the motor flange, axle bores, and gear teeth using the parameters you made, and add key features like countersinks and fillets to match hardware. Move to the assembly and place parts with fastened or revolute mates. The correct mate choice defines motion and stress points. Make sure to test clearances by dragging parts. Detect collisions early so you avoid late-stage redesigns. To finish, validate your assembly by checking mass properties, center of gravity, and interference detection so the robot behaves predictably. Create exploded views and technical drawings for fabrication, and export step or native files for CAM or simulation. Once done, make sure to lock critical mate references to prevent drift during edits. If mates fail or parts jump, isolate the conflicting mate, reorder features, or suppress the mate temporarily. This resolves most assembly instability without losing design intent.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.